This video is actually letter C on number 5 of your notes. It's called combustion analysis to determine empirical formula. They're actually going to do empirical and molecular formula on this problem, but a lot of times they take organic compounds, so ones that contain carbon and hydrogen or carbon, hydrogen, oxygen, and they can burn them and figure out the empirical formula based on what is produced in the reaction. So let's say we have this compound. It's actually, we're going to try and figure out ascorbic acid, which is vitamin C. So we have this compound in the formula. Again, we're trying to figure out, what number goes there, what number goes there, what number goes there. So we're trying to figure out the formula of that compound. So what they do is they burn it in oxygen. And as you know, organic compounds, or hydrocarbons, when they're burned, produce carbon dioxide and they produce water. So they know how much of the compound they start with. They burn it till it's completely gone. They collect the CO2 and collect the water and see how many grams they have of each of those. So if you think about this, all of the carbon that was in here is now in the carbon dioxide, so we can figure out how many grams of carbon there are here. All of the hydrogen that was in there is now in the water, so we can figure out how many grams of hydrogen are in there. And then we can figure out the oxygen carefully. You got to be careful with the oxygen because there's oxygen right here that we would have to take into account. So first thing, let's figure out how many grams of carbon are in this. That would also be the number of grams of carbon in here. So eventually we'll be able to get to moles of carbon, hydrogen, oxygen, get the ratio of them, and get our formula from that. So I'm essentially just going to say, well, we have 0.1869 grams of carbon dioxide was collected. I'm just going to do the percent of carbon in there. For every 44 grams of carbon dioxide, that's just how much a mole is, carbon dioxide. For every 44 grams, it contains 12 grams of carbon. There's 12 grams of carbon out of every 44, so that cancels with that. Our grams of carbon are 0.05097. Notice I'm leaving quite a few decimal places here. We can get our grams of hydrogen out of that, so we can say 0.0510 grams of water. Let's say, well, for every 18 grams of water, it contains 2 grams of hydrogen. There's 2 grams of hydrogen for every 18 grams of water, so that. And you get 0.00567 grams of hydrogen. Remember, those are in grams. We cannot get a ratio of those. Plus, we still need to know the oxygen. So with the oxygen, don't try and figure it out based here and here. Okay, it's not going to be possible to do. What you want to do is figure out, because we don't know how much oxygen was here. We know there's that much carbon and that much hydrogen. Add those together, subtract out of that. And that will give us our oxygen. So we're going to take 0.1247 minus 0.05097 minus 0.00567. So that gives us 0.06806 grams of oxygen. So now we've got our carbon, hydrogen, oxygen grams. Now we're back to a normal empirical formula problem. So we're going to turn this into moles, turn that into moles, turn that into moles, and then we'll get our ratio. Okay, so I'm assuming you guys can turn things into moles right now. I divide this by 12. That's 1 gram per mole. Divide that by 16. So here's my moles. This becomes 0.004248 moles. This is 0.00567 moles. And our oxygen is 0.004254 moles. So now we can get our ratio of our moles. Remember, divide by the smallest one. You can kind of tell these are pretty much the same thing, so they're going to be in a 1-to-1 ratio. So if I divide all these by the smallest one, essentially this one, divide them all by 0.004248. I get approximately a 1, a 1.33, and a 1. So to get that into whole numbers, I can just triple it. So this becomes a 3, that becomes basically 3.9904, and that becomes 3. So our formula is, this was carbon, C3. So for every 3 moles of carbon, there's 4 moles of hydrogen and 3 moles of oxygen. Again, that's the empirical, the most reduced form. That is not the actual molecular formula of vitamin C. So let's figure that out. So if I told you that the molecular formula of vitamin C has a molar mass of 176, I believe, grams per mole. That's what the molecular formula is. Again, this is your empirical. It might also be the molecular. If we add up 3 carbons is 36 plus 4 hydrogens would be 40 plus 48 would be 88 grams per mole. So this is 88 grams per mole. Remember, the molecular formula would be double or triple or quadruple or whatever it is of the empirical. Well, 88 goes into 176 exactly twice. So the molecular must be C6H8O6. Again, just figure out how many times this goes into the molar mass of the actual compound.